We'll get started here. I wanted to thank everybody for joining us today. I'm Russ Armstrong with Boast.ai, director out in the Toronto area. I wanted to thank everyone for coming today and joining us in another installment on Boast.ai's webinar series. Today we've got an amazing session on a super relevant topic that I was extremely excited to hear more about: how to launch your first AI ML product in 3 months. And before I introduce our speaker today, I just want to remind everybody to enter any questions you might have in the chat box on your screen. And also, please keep an eye out for a recording of the presentation that will hit your inbox later today. Okay, well, I'd like to introduce you to Manish Gandhi, founder and CEO of Gradient Ascent. Manish has over a decade of experience in AI and is a thought leader in the space, and he's going to walk you through the presentation today. Over to you, Manish.
Thanks, Russ. Hi, everybody. It's a very exciting time for webinar. As you can see, there is a survey that's on the webinar right now. If you can all just take a quick second and fill out this survey, it would definitely help us sort of target the content better to what you are interested in actually learning about and doing. So just let's take a second here, and then we'll get started. Excellent. So as Russ mentioned, my role is to help companies thrive in this coming AI-powered world and help them sort of get the most out of their data by applying machine learning and AI. We've done about 20 of these types of projects. And one of the reasons why the topic of today's webinars is how to sort of do this relatively quickly, reliably, and efficiently, really within 3 months. So that's what we want to talk about today. The key thing I want to highlight here is there are really 2 major sort of applications, the reasons why people will apply AI within their business. One is to innovate, make their product, their service better, to drive additional revenues, incremental revenue, grow their mind or market share. Or the other option, which a lot of non-technology companies often do, which is all around sort of operational excellence. How do we improve our operations, make them cheaper, faster, better, safer, to drive sort of profitability and customer satisfaction, as opposed to sort of do pure product innovations? So at a very high level, there are really only 2 sort of benefits or applications of what we are talking about here today. And as I'm talking about it, it would sort of be helpful for you to also think about, if you were to apply AI, why would you apply it? Is it to drive that innovation and improve your product, or is it to improve your operations? So I saw in the survey, and I'm just going to take a quick look here. I saw in the survey that we have quite sort of a diversity in terms of knowledge of both AI and where you are in sort of the life cycle of applying AI. So we're going to sort of get a quick ground set here for everybody and try to get a little familiar with what is AI, data science, machine learning. The key reason why a lot of these technologies exist is, and one way to think about it is to answer a question like this. How do I know, and how do I compute whether there is a table in this image? So if you all sort of take a second and sort of think about how would you decide, how would you potentially write a program that figures out whether there's a table in a photo or not, how would you do it? You might look for, oh, it has a surface, but lots of things have surfaces that are not tables, including platforms or cars or buildings, floors. Oh, it has legs. Well, animals have legs too. So really how you define these objects, this has been sort of a challenge in computer science for a long time. We know when we see it, we know what a table looks like when we see it, but we are not entirely sure of how to actually arrive at that decision, especially because it significantly sort of varied and complex, right? A table comes in different materials, different sizes, different shapes, different legs, different number of legs, different colors. So to account for all these variations with a set of what we would call sort of programmatic rules is very difficult. So the new approach, really this AI approach, and I'm simplifying here for those of you who know AI very well. This is not sort of meant to be a complete comprehensive view, but the gist of what we can do now is, instead of us coming up with the logic, which is really the traditional programming of, I'll take my data, which is my photo of a table, and I'll write a program. It says, okay, look for a surface, look for legs, and if it kind of sort of looks like a table, then the output is, yes, it is a table, or no, it's not a table. That's the traditional approach. So instead of taking the traditional approach with machine learning or AI, I am sort of treating both of those terms actually interchangeably. And we'll get to that in a second. But with these new approaches, what I can do is I can actually tell the computer to come up with the program, which is really the logic, instead of a human coming up with it, by essentially showing it thousands and thousands of examples of what different tables look like and things that don't look like tables. With that and these new AI algorithms, you can essentially have the computer generate a program that will identify tables versus images. Now, as I said, I am using the term AI as a very umbrella term. It includes, to me, data science, machine learning, neural networks, some of which are techniques, just to sort of keep our conversation broadly similar. In some cases, other companies use the word AI as a cognitive application. It's when you are using a computer program to really generate audio processing, image processing, sort of more cognitive type of abilities that only sort of humans can do. They call that AI. There is really no agreed term. It's very much a marketing term. So just to simplify here, I'm just going to use the term AI to mean sort of include these broad classes of algorithms and solutions that do what I sort of just described here. Fundamentally, they all do pattern recognition. They are looking at these thousands of tables and finding a pattern, which would be hard for even humans to find, and decide whether there's a table or not. So I think most of you are now probably thinking, enough with the tables. How does that really help me? That has nothing to do with what I want to do. What's neat is this fundamental challenge of, is that a table or not, can be expanded into sort of a broad class of problems and challenges that really exist all around us, both in our personal lives and in business. So instead of asking the question, does this image have a table or not, I could ask the question, who is this person in this image? And that's actually structurally a very similar problem. If I stop talking about images for a second, I could also ask the questions of, I have historically collected hundreds of thousands of leads in my business. Some of them converted to a sale and others didn't. Which is, again, similar to this question of, is that a good lead or is that not? Is that a table or is that not? These type of classification questions actually exist all over the place in business. What type of contract is this? Is, again, a very similar type of problem. So suddenly, if we can sort of build these algorithms, which are, again, fundamentally a pattern recognition type of algorithms, we can apply them all over the place. We can apply them to do prioritization, forecasting, organization. We can use them to make predictions about financial risk. So if you're a financial company, you might decide to sort of say, should I lend to this applicant? Should I loan them money or not? Because essentially you're trying to predict, will they return me my principal and pay my interest or not? More complicated examples of essentially sort of this same type of thinking is still very much, you get into things like chatbots, things like self-driving cars, even something that we would think very human-like, sort of generating music or art, have very similar type of pattern recognition problems. That being said, these are not just sort of one algorithm or one approach that does all these things. These are many hundreds of different algorithms and approaches that come together that sort of fall under this umbrella of AI that now allow us to do very sophisticated pattern recognition to then automate or really do human-like things. By the way, if you have any questions, feel free to just sort of put them in the chat, and I will answer them as I go along. So want to just sort of get you familiar with some of this. This conversation is not a lot about heavy into technology, but I just want to sort of get you through build you some familiarity around how this actually works. So the idea is you have inputs and outputs. So inputs and outputs are basically, input can maybe an image, and the output is whether this image has a table in it or not. The input may be a loan application, and the output may be, did this person actually repay me my loan or not? The input may be a sales lead or an opportunity, and the output is, did they convert and actually become a customer or not? So with these input-output pairs, you can use the algorithms, it's called sort of a training process, to actually create these models, which then will let you input other loan applicants or images or leads or opportunities to generate or really make a prediction on the output that you are looking for. So I take my historical data, the inputs and outputs, it's also known as labeled data, and apply or run it through sort of this training process. I have to identify the right sort of model or the algorithm I'm going to use to actually train this system. And then if the system is accurate enough, I can then use it to make future predictions and automation. We'll get into a bit more of this when we review some of the cases that I would like to talk about today. And then you might say, okay, so how is this different from what we used to do before? So remember, fundamentally, before the code, the program, computer program, was written by a person. A person would sort of figure out the answer in their heads and then essentially transcribe it, write it as a code so that a computer could understand it and put it there. Now the approach is very different. Now the approach boils down to, I want a lot of data that has both the question that I want to ask, should I lend to this person or not? And the answer, I lent to this person and then they gave me my money back. I combine these questions and answers to train these models. So while this is still quite similar to how we used to do traditional computer programming and software development, this is different in some meaningful ways. And a lot of what we're going to be talking about of how you actually can do this quickly while reducing your risk and sort of have machine learning and AI be part of your products or your business, these are some of the key things to keep in mind. While not all of them apply to you, they do play a role in how you make decisions. So, for example, data plays a key role. I think all of you have heard this, all of you know this, so I don't want to spend a lot of time on it. But really, data is critical because data is what you use to find these patterns, to build these models, to really create ultimately the AI that you want. Now, with data, it is critical, and I'm going to spend a bit more time on that one than the rest of these bullet points here. It is critical to sort of collect this data the right way. You want to both sort of the input data and the output data, really the answer you want to make a prediction on, and potentially even outcome data. What was the business impact of this down the road? Other things to keep in mind, the reason why data is so valuable and powerful is that the data advantage sort of compounds over time. The more data you have, the more data you can get. Sort of, data begets more data. It has its own form of gravity. So it's important that you spend time thinking about whether you're ready to do AI right now or not. It's almost irrelevant, but really think about what is the data strategy of your business and make sure you get that right. And you are starting to collect the data now so that even, if next year or the year after is when you really want to invest in AI, you will have the data you need to do it. The other things to think about here are, the AI development process is very experimental, hypothesis-driven, and iterative. What I mean by that is until you actually start building these models, you don't actually know how good they will be, whether they will work or not. Of course, you can have a hypothesis. You can sort of assess feasibility of will I be able to do this or not. But until you actually do it, you won't know how well it performs for you. That obviously makes things slightly riskier than you're used to in the past. The other part of this is the responses that you get are probabilistic. So the AI system never really tells you that there is a table in this photo. It just says there is a 70% likelihood or 80% probability or 90% confidence that I actually have a table in this image. How you interpret now these numbers, these probabilities, and this data points is up to you. And it's highly related with how your customers would want you to do that. The second part of it is inaccuracy. The systems are not 100% accurate. The example I would like to use is most of you probably use some form of voice assistant, whether Siri or Alexa or Google. Those systems are sometimes 90% accurate, other times 70% accurate, and other times really just completely inaccurate. Traditional software, if you launched a piece of software that was 20% of the time, or that gave wrong answer 20% of the time, you probably would never launch that. You would probably never use that. But with AI systems, the expectation is different because that's inherently how they work. So it's an interesting perspective. It's a little bit like forecasting weather. We all understand and accept the uncertainty, the inaccuracies that comes with that part of in a way, our life and the business. The other piece is that once you sort of build these models, for a majority of these systems, you're never really done. They will require ongoing care and feeding because, one, they're never perfect, but two, they have what we've started to sort of call a half-life, where the idea is really models become outdated. If I'm making my lending decisions based on historical data, as I accumulate new historical data and the loan performance, how I make loan decisions changes. I am learning. These systems can learn over time. So while they don't require constant care and feeding, where you need to sort of retrain them every day, they do require ongoing investment, and you do need to be aware of the fact that these models will need to be updated. Other things to think about, most of these models that you build are narrow and specific. If you remember, a few minutes ago, I was talking about how there is no one sort of AI algorithm. There's no one way to find patterns in the data. There are hundreds of different approaches. So really the one approach that you build in your business to, let's say, predict whether a lead will convert into a sale or not is very different than the one that you would use to, for example, identify whether work environment is safe or not based on some camera and video data. So these systems are very narrow, very specific. There is no general purpose approach, although that is an area of active research. Now, keep in mind, these systems are not empirical. These systems are empirical. They're not rules-based. I couldn't come up with a set of rules that describe what a table is, which is why I needed to sort of go find thousands of table images and have a machine do this. So they are hard to really understand and explain. In a way, they are very opaque, right? They're not fully knowable because you don't understand every single table in the world. You only understand a few of them. And because they're this sort of mathematical in nature, they are not in a readable code format. There's not programming that a person does. There's actually a form of programming that computers do. So they're really actually very hard to read, or actually impossible to read, but very hard to understand, which means they're hard to QA and debug. So if you're a technology company and you're used to your QA processes, you would have to look at AI QA process differently. So with this sort of differences in mind, and I know this kind of seems like, oh my God, this is very different, this is very new. Yeah, but also a lot of what you know about traditional software development still applies. And with these changes comes a lot of benefits. It's now you have the ability to really be able to do things that you could never do before. Now we can talk to our computers. Now our photo libraries understand what's in our photos, so we can search through our photos instead of having to organize them. Now you can really start to do things you could never do before. So as you are thinking about your business, that's one of the questions I would ask. While there are opportunities for you to automate the processes you have, so a computer can read all the forms or documents that are coming in and automate all the follow-throughs with that, potentially what can you do now that you could never do before, and in a lot of ways change the game. So with this sort of grounding in what AI is and how it's different and why it's so special, what does it let you do that you couldn't do before, let me just run you through some quick case studies so you can understand how very diverse set of companies are able to use AI to very quickly bring change to their business. So this is sort of first example. This is a Canadian company, but they have a large presence both in US and Canada. They provide an e-commerce platform and site where consumers can buy electronics, furniture, and other types of products. But they also provide lending and provide loans to these consumers to purchase these products. And one of the things that this lender, this client, is always sort of trying to better understand is, who should I lend money to and at what interest rate, and who can't I lend money to? Who will never give me my money back so that I'm losing my money? And being able to predict that quickly in an automated fashion online has a huge impact on their business in terms of being able to serve more customers, have greater revenues, and have better margins. So the challenge here is really when you go online to their site, you as a consumer are filling out very basic pieces of information. You know, your name, where do you live, who is your employee. It's not like you are about to or you will be able to, or you are really even allowed to provide all your financial data, or you really want to provide all of your financial data, your last year's worth of transactions, your income statements, things like that, to this company. So you're really providing some very basic information. So the problem is, can we use last 10 years worth of data that this lender has, where people have filled out these very basic online forms, then this company has manually made a decision whether to lend money to them or not, generally over a phone call even, and then see whether these consumers actually paid the money back or not. Using this historical data, last 10 years worth of data, I believe it was about 100,000 historical loans. Now we're able to sort of generate a model for them that they can use to automate that process. So that now when someone goes online and fills out this form, we can automatically make a prediction based on that, whether you should lend to them or not. And if you should lend to them, how risky are they, at what rate, and based on that, whether they will pay the principal and the interest back to the lender or not. This is a very common application within the financial services industry. But again, I would sort of say structurally, when you think about this problem, this is actually a very similar problem, again, as to what I would say lead scoring or lead classification. If I get a lead, can I compare it against the historical leads I received to see whether this is a good lead or not, whether I should, whether this lead will convert into a client or not. And even if, and even beyond that, can you then use that insight to create a very personalized journey for this client, this potential client, to convert them into a customer. By the way, if you have any questions, feel free to just throw them up. The next one, this is a very different sort of use case. This is for in the retail context. The idea is the ability for a retailer, say a grocery company, can they allow their customers to essentially purchase a product or add a product to a shopping cart just by taking a photo of it. Maybe some of you have seen it. Amazon's app already sort of lets you do this. So we've had a technology company, it's sort of a retail-focused technology company, say, can we build this kind of capability for our customers? Again, the idea and the approach here is to really understand what sort of data is available, what is the right approach. For example, in this case, some of the more advanced sort of deep neural networks and more latest approaches are actually not appropriate it's for this type of a use case where you really have to go and explore of those hundreds of other algorithms, what is the right fit to be able to do that. I should highlight that for both of these applications that I'm talking about, we are the timeline was less than 3 months from the beginning to sort of a validation and launch. And then last but not least, again, a very different use case. If you are familiar with WebEx or Zoom, there are a lot of sort of competitors in that space: video conferencing, web conferencing. There's a global company, again, headquartered out of Canada, that is focused on innovating in this space to sort of say, how can we make this better? And started out with the vision of this idea for a few years from now. Wouldn't it be cool if at the end of your meeting, you could automatically get meeting insights, meeting summaries? So you didn't have to take notes. All the action items, the agendas, the deadlines were all automatically summarized and made available to you as a user. How do you sort of go about building the right minimum viable product for a solution like this so that over the next few years, you can arrive at the right, a very compelling, differentiated product in the market? So they've already sort of launched this product in the market. You can sort of go check it out. And the gist of it is, what is the right approach to start, and then build up from there. Once again, the advantage of sort of getting to this sort of an MVP relatively quickly is it also lets you collect data, which over time you can use to retrain and train your models, leading to a better solution. If you sort of think about even voice transcription, these voice assistants I was talking about, a few years ago, they were all very different, or they were all very, compared to today, they were significantly worse. They wouldn't actually understand you when you were in noise, when you were in car. But now with additional data, with newer algorithms, they are able to be much better quality. So there is inherently this idea of an iterative approach to improving these types of systems. Do not have an expectation of 100%, or even I would really say 90% accuracy going into a solution like this. So we have a question here, so I'll just sort of take a look at it. It's from Kara. Thank you. What are the problems associated with real-time analytics for neural nets? What can be done and can't be done? So highly technical question. Maybe, Kara, we can take this offline, but sort of a very quick response here would be that it's sort of the amount of data that you have both to work with and to train. And really, when you are doing real-time analytics, what are you actually looking for? Are you detecting anomalies, or are you looking for classification and patterns? What are you trying to do with it? Because depending on what the use case is, your challenges will be very different. But there has been a lot of progress in terms of real-time analytics using neural networks, and now they're being deployed sort of all over the place. And actually a good example of that is actually voice speech transcription. It's more or less more or less stream analytics based? Good question. So now I wanted to actually jump to, great, so AI is awesome. It can let us do some cool things. It's different, and great. Few other companies have tried that. How do we actually what is the path to doing that? So I want to sort of start out by just sort of talking about what are some benefits of adding AI to your products, and in some sense, right now, there's still an opportunity strategically to differentiate whatever your product or service offering is by leveraging AI. But when we look few years out, over the next 5 to 10 years, the expectation is that every product, every service, really every process will be leveraging AI. So in a lot of ways, it will just be a default expectation, and very difficult to exclude it as part of a company's roadmap. And so it becomes critical to get started with it sooner rather than later, because of the need for data and assuring that you have the right data stored in a secure and a privacy sensitive way. You're building the core competencies you need to get started. I do want to sort of talk about one of the questions we get asked the most is, great, AI is awesome. What do I do with it? How does it apply to my business? Help me brainstorm. Help me think about the opportunities that are within my business or within my product to apply AI. So I'm not going to talk a lot about the process part of AI right now, but in terms of product innovation, new products, or new features, here are some ways you potentially are able to brainstorm and think about how AI really makes sense within your business before you sort of go down one path, one vision, or one roadmap with your product. So, for example, one of the things AI really does is it can automate sort of verbs. So if you look for verbs that are part of your process or part of your business, part of your product, you are able to sort of say, can I automate these things? So if you have a lot of paper processing that happens in your product or in your business, one of the common verb associated with it may be organization. People organize, or people read because they are trying to extract key pieces of information from these documents. You would be able to use AI to automate those things for your customers and your users. The other piece is, and this is sort of a rule of thumb, but things that take less than a few seconds to do by a human, given data, now you're able to automate quite quickly and quite well. So can I assess a faulty manufactured part, for example, or can I, decide whether to not hire, but interview this candidate based on their resume or not? Because now you can sort of do this sort of resume analysis, basic decision making. In some cases, you might be able to sort of think again really far out and sort of reimagine processes entirely. So Google sort of saying, even 10 years ago, hey, why do we need a person to drive cars? Why can't we just have computers driving cars? So self-driving cars is sort of very much a reimagination of what's possible, broadly the topic of autonomy. The other piece you may want to look at is around data differentiation. What is a unique data that your business has that other businesses don't have or competitors don't have? So for example, when I think about the video conferencing example I just showed you, this is a question that we had asked them, and the answer to it led to really the vision that you saw in that previous slide. Because they said, calendars have event information, but really the unique data we have is meetings. People have meetings on our product, on our platform. So it is a piece of data that no one else has. And so if we can capitalize on it, if we can unlock the value of it, and if we can really show customers, delight customers by giving them better experience, then that's enormously valuable for their customers, which means for them as a business as well. Other ways of looking at it is, of course, the tried, true, and correct way, which is working with customers to better understand what challenges they're facing and coming up with ideas that may have an AI application. Now, one of the things I would like to sort of stress here is oftentimes clients come to us and sort of say, hey, we would love to sort of do something with AI now, sort of help us sort of figure it out, and come up with ideas that you really don't need AI for. And so I would strongly encourage you all to sort of say, AI can be very complicated. So if something can be done without using AI, please do it that way. It's far simpler, it's less riskier, far cheaper, and really the type of experience you can provide is way better than an AI-powered tool. That being said, there are things that you just won't be able to do without AI, and that's really where AI can shine, where your investment is worth it. When should you do it? And really the point I want to highlight here is this idea of virtuous cycle that comes with having data and extracting value from that data. So really the answer to the question when is now, right? Like you really should be thinking about your AI strategy and your data strategy now, because the more data you have, the better data you will have, and the more data you'll be able to collect. It has its own sort of gravitational pull in terms of the types of experiences you can build. As you can see, like Google over time, because they have a better product, people use it more. And because people use it more, Google gets better data. And because Google has better data, Google can create a better product. And this virtuous cycle compounds and has sort of an enormous benefit over time. As you know, with any compounding, if you start 6 months before your competitors are more than 6 months behind, because you are that much, you have that sort of compounding benefit. One of the other things I want to highlight here is this notion of 3 months, right? I've always been sort of talking about, do this in 3 months. Whatever you do, the first thing you do, try to do it in 3 months. And there's a reason why I say that. The 3 months is a number that I've really picked because it's nice, it's quarter. But really, it could be 2 months. It might be 4 months. That's irrelevant. I'm just saying, don't pick your first project and then have it be something that takes a year or 2 years that requires a PhD to do it for you. Just because the amount of risk that you are taking on at that point is very difficult to then actually manage. In a lot of ways, you won't really know what you are trying to validate. So I highly recommend you pick a short timeline, commit to doing something, and get it out the door, because a lot of the learnings, as I said here, are not in just building the model, but it's about how actually it gets deployed, how you end up using this technology. Who should be doing this type of work? So you could, of course, do this in-house, or you may outsource. And I don't know if there's a right answer. But what I will say is that for most companies, especially technology companies, machine learning and AI will become a core competency for your business over time. It's inevitable. There's no way to there's no way to deny that. You may say that now is not the time. We don't, our customers are not asking for AI, our competition is not doing it. We don't have enough data. There are a variety of reasons why we don't want to do this now. But starting to build the competencies, potentially bring in either people or train your employees to build this competency in-house over time will yield you superior return on investment, because again, even if this year is not the year when you do AI, it is inevitable that in the next few years you will need to invest in this. So at the least, you may want to start to build the talent, but two, start to get your data in place, start collecting the right data, storing it in the right way, labeling it, and have it in a ready-to-go state so that when the time comes, you're ready to invest in this. The other thing I want to highlight here is, aside from adding potentially new roles to your teams, it's important to understand that because AI in a lot of ways is different than traditional software, it massively impacts the existing roles. And this description here is very technology company centric, but existing roles within your other parts of your business. Your product managers, this is sort of an area of common concern. If your product managers do not have the right sort of data products and AI background, they will struggle to actually get these things shipped. Because how you design these products is different. How you QA these products is different. How you support these products is different. Remember, if your product, if your AI model, let's say, is 90% accurate, which means it's wrong about 10% of the time, how is your support team, your marketing team, sales team actually talking about the uncertainty and the inaccuracies within these models, right? Because they need to be ultimately be the ones that are working with your customers to setting expectations, or when your customers get themselves into trouble, actually helping them get out of it. So being able to sort of think about this in an end-to-end way and how it impacts others is a critical aspect, and really a common area where we see companies fall down because they just think, oh, this is just an API, or I have 2 PhDs with data science background, and they'll build some really cool stuff, but when it gets in front of customers, they don't understand it because it's not really designed with this end-to-end thinking in mind. And this is really, again, sort of the framework that you can use to think about this. And we'll sort of start from the bottom here. At the foundation pieces, you should be thinking about, how does AI impact your culture and process, your talent, tools, and data? And impact is in terms of whatever you have existing, but also what you need to actually be an advanced sort of AI company. In terms of the AI project itself, as you're sort of thinking about this 3-month type of project, there is the start right phase, which is all around strategy. Like, what are we going to work on? Why are we working on it? What does success look like? Building phase, which is the actual development, and then launch. I mean, no surprises there. But we will go into more details with any of these. And then the highest chart there is really around the different sort of steps and the phases you should be expecting as you are doing this. There's the initial ideation and strategy. Then you are really trying to sort of understand the data that you have. Then it's the analysis and prototyping of your data and the models. Then it's really the core model building, which is an iterative cycle. As I was saying earlier, until you actually start building these things, you don't know if they will be effective or not. And then you go into sort of the deployment, maintenance, and the growth mode. Some common strategic questions as you are starting out that we often run into, how do we know what's a good MVP? And by MVP, I mean a minimum viable product, which is really your smallest combination of capabilities that are desirable, that are feasible, and that are viable. Right? And so it's critical to sort of really understand the desirability. What is it that the customers really want or need? What's viable? What is something they will pay for or will be able to monetize? And feasibility is one area where, if you don't have this type of talent in-house, you may really sort of struggle to figure out. But in that case, like, get help, ask others. There's plenty of people who understand this, because as that little comic on the right side says, with AI, it's often difficult to know what's feasible and easy, and what's feasible and really hard, and what's almost impossible. The other issue when it comes to sort of defining what is the first project you work with is really around prioritization. And that boils down to, do you have the right return on investment? High enough return on investment? Are you taking on too much risk? What is the time to market? How quickly can you get it done? As I said, you don't want to pick something that's going to take a long time. What gives you the right opportunity to maximize your learning? And then in terms of data, where do you have the data to be able to actually do this in terms of feasibility, but also doing something that allows you to collect the data that you need for the future enhancements to whatever you're building. So what can you build that allows you to collect even more data? So if I think about, again, the video conferencing example, going out with a basic insight-based system, but then collecting action items from meetings allows them to, over time, automate generation of action items. Should you build versus buy? A very sort of traditional and typical question. The answer is, I don't think there's a lot of surprise here. There may be sort of AI-specific understanding around, what's actually valuable, versus what's actually commodity. But your standard question. One differentiation I would mention here is this notion of, if I end up using an external supplier or an external API, am I potentially training them to do something that puts them in a position, strategically better position, and potentially with leverage over you, or potentially even become a competitor? So something just to think about. With traditional software, that was never really the case, because you using a third-party API didn't really make them any better. But now, with your data, with your input data, they may be able to get much better, much quicker, which could be a risk for you. So an example here would be legal software companies that use AI can, over time, potentially be in a place where they can provide legal services to compete with the lawyers who actually use their product and train their data. So an interesting conundrum there. And then it boils down to data. Do you have the right data? Do you have enough data? Is the quantity enough? And that's a very hard question to answer broadly. But really what you're looking for is variability. So for example, if I want to predict weather, if the historical weather data I have only contains, let's say, data from June, July, and August, there is no way I can really build a model that will accurately predict weather in January. So is your data representative? Is your data have the variability that you need? And then is the data actually accessible? So is it in a format where you can access it correctly, properly, and then actually useful? And then one last thing to sort of mention there is, in terms of data, a key aspect of the strategy may just end up being around what data should you be collecting that you are not collecting right now, which will sort of get you into a strategically better position over time. Again, not necessarily something you should be thinking about for the 3-month project, but definitely something you should be thinking about as you're sort of building out these competencies. I want to sort of jump to sort of this key slide here around, as you are starting, building, launching, and then sort of maintaining and growing these tools, what are some key things to keep in mind? So as you are starting, it really helps to know why you are doing what you are doing. I think oftentimes companies are interested in AI just because it's cool. Nothing wrong with that, but then sort of know what your investment looks like and what you are trying to achieve is very different than the type of investment that you may have to make. Broadly speaking, from your roadmap, pick something that's small, simple, it's valuable, but it's not critical. So if it's a core part of your business process, so if you are a financial lender and we are potentially replacing your core financial decision-making process of whether I should lend you money or not, that's very risky. And so it's great because it is very valuable. Any impact we can make there will dramatically improve their business, but it's also very critical and very core. So if we get it wrong, that's very risky. And that's where it again comes down to, manage expectations, right? Because your initial model is not going to be perfect. Frankly, there is really no perfect models. So how do you sort of manage expectations both internally and externally to make sure that customers and partners and CEOs and boards are not expecting something magical when you are really sort of starting with something basic and getting out in front of customers? I think there's this perception media has created in the marketplace that AI can do some very magical things, but we are not quite there yet. And really, you want to be sort of optimizing for learning because you are trying to learn, iteration because this is not the final solution. So any investment you make into tooling, do it in a way where it lets you iterate faster with less manual effort. And then again, for data, because you are trying to collect a lot of data. In terms of building phase, I think the key thing I want to highlight is that be flexible because your data will change and your model performance will change what you end up building, what you can actually ship at a good enough level to your customers. Because once you go in, let's say you started out by saying that I would like to accurately forecast our customers' revenues for the next 6 months. And then as you actually get into the data, you realize that really all you can do is next 6 days. I think you have to sort of follow that data and then recognize that we are going to ship with next week's worth of forecasting, but now we are going to start to collect the data we need and invest towards getting to something that is 6 months of forecasting. There are some design considerations around feedback loops to ensure that your model can get better over time. We didn't talk a lot about ethics and privacy in this session, but also other areas of concern. When it comes to launch, where we are seeing people fall down again and again is around sort of lack of thinking about this end-to-end. It's the technology teams thinking that, this is just a cool new feature and we're going to get it out there. And this is just like every other feature that we launch. It couldn't be farther from the truth. That's when teams get into trouble. Really focus on almost over-communicate. Like make sure you're training your cross-functional teams, including support teams and marketing teams, on what AI means and how it's inaccurate and the model that you've built, when does it work well and when does it not work well. And ensure that your customers know how to interpret the model that you've built for them and the prediction that you're providing for them so that they don't get themselves into trouble by thinking that the forecast you are giving them, even though it's correct only about 80% of the time, they think it's correct all the time. And then they may end up making serious business decisions on that. Really, I think transparency plays a key role in these types of project success because it maximizes learning. It sort of builds a culture of, hey, it's okay. This is an iterative process, and you can sort of show progression. And so, by after doing these 20 projects that we've done, here are sort of some of the key success principles that we really believe in and we think you should sort of really believe in as well is transparency, pragmatism, right? Like follow your data, be data-driven, hypothesis-driven, and it's okay to sort of change your mind. Think end-to-end. Don't just think this is a small little technology problem and I've hired a very smart data science PhD and they're sitting in a corner and doing some cool stuff, but no one else really understands what they do. Get to market as quickly as possible, because that's really the best way for you to get data and improve your models. And really focus on the customers and try to sort of meet their needs. I mean, I guess nothing new there. So yeah, with that, I mean, our hypothesis is all about, this is very different. I mean, it's not rocket science, it's not difficult, but don't approach this as, oh, this is just another API or new technologies we're going to start using, because that often does lead clients into trouble. So yeah, with that, I will jump to questions. And I see that we have a few questions, so I'm just going to take a second here to read them.
Hey, Manish, while you do that, thanks again for that presentation. That was fantastic. It was a great overview of AI and your process and thought process around it. I really appreciate that. One, maybe just to kick it off while you're continuing to do this, is just around the data. In the data, maybe I'm thinking about a project and I'm not quite sure if I have enough data around it. Are there public libraries available? Are they quality? Are there fees associated with accessing public libraries of data that could help me in my process of building out an AI model?
Yeah, there are a lot of external pools of data available. Even there are some industry associations now that are trying to convince companies to pool their data together, because pooled data will perform better. A lot of this is still in its infancy. So there are paid data models. Even some universities license the data they collected for research, which you may find useful. But I would say that the data you collect for yourself over time will be far more valuable, differentiated, and relevant to what you're trying to do than anything else you find externally. And when it comes to data collection, creatively typically trumps almost anything else. If you can creatively find the data or get it from someone else, or the best case scenario, like go to a customer and see if they will share the data with you in exchange for, free license or something, that actually ends up being extremely effective. So yeah, I mean, there's no like a scripted answer for data, but a common issue and room to be very creative. And if anyone has sort of specific data related questions, or if they're looking for libraries or something like that, I'm happy to sort of discuss that offline.
For sure. Just another question, just around the IP ownership and around the privacy around it. I know you said like the accuracy of some of the models might not be 100%. Is there legal ramifications that we need to consider when you're rolling out some of these models, granted that you say it's not 100% accurate?
Yeah, so good question. No model is 100% accurate, right? So it's I haven't seen one. Maybe it's possible, but that's rarely the case. But that's okay, because currently it's typically people doing those processes, and people are not 100% accurate either. So the organization, once sort of you explain the context, they sort of get it. But two, there's a couple of ways to go around it. One, how critical is that process that you are now automating using AI, or you're making a prediction? If it is very critical, understand what is a good enough level of accuracy and see if you can beat that. And if it is very critical, we work with a nuclear power plant. There's no way there are some parts of their process that we want to touch, because I always say, even if I'm 99% accurate, you will never trust anything we do for you. So let's not sort of go there. The second thing is the notion of human in loop. A lot of we didn't get into the details of the design, but you should be thinking about designing the AI output, the answer that the AI generates, and when you present it to the user in a way that the user understands that this is AI generated, this may not be accurate, what are the factors they should consider to really sort of make their decision. I mean, don't just throw probability, because hey, my answer is 78% confident, will just confuse them even more, because they won't know how to interpret it. but sort of provide them that training, that coaching, that on-the-spot interpretive guidance in terms of how to actually use this data. So human in the loop, interpretive guidance, process changes, and then fundamentally, like if it's a very critical process where either the impact would be potentially catastrophic, maybe that's not the process you want to start with in terms of converting to AI.
Understood. Well, I see we have hit the top of the hour here, so I do want to wrap it up here. I know there's some outstanding questions in the chat, and Manish will reach out to answer some of those individually. But I did want to thank you for the session today. That was amazing and very informative, and I appreciate the time you took to share some of your industry insights.
Yeah. Thank you, everybody. And those of you who haven't, who we haven't been able to get to your question just yet, I will be in touch with you shortly. I'll shoot you an email. Thank you so much. Thank you, both team too.
Absolutely. And yes, that will be a copy of the session today will be sent over to your inbox. So keep an eye out. Thanks again, and join us again in the future for another Boast.ai webinar series. Take care.